Good morning. So this is just a quick video to explain how to use Polar Plot. This is a software from a G4HFQ, a guy from UK. What is the purpose of this software? This software is dedicated to check for you the antenna directivity on the radiation pattern. So if you build your antenna, a beam antenna, of course, or if you buy one antenna, it's advisable to check a bit, especially if you have a very difficult environment with a lot of houses in a very urban area. It's very, very important to check that your antenna will behave nicely. So what you need the software, Polar Plot. You need a transceiver with audio output here, a plug with audio output. You need a computer with a microphone or line-in input on a cable here in order to link the output of the audio to the computer. So this is regarding the software on the radio, what you need. On what you need also, you need a tiny essay. The tiny essay, of course, can be used for many purposes, but one good thing with this tiny device is providing a RF generator. So we are going to use the RF generator with this antenna plus the tiny essay in order to check your antenna radiation pattern and directivity. So according with all the parameters you have, I will show you after. You need to calibrate your input here. You need to choose also the input. So here it's according with your computer. So for me, I choose the line in. After that, I'm going to show you need to calibrate your audio output from the transceiver to the computer. Here you need to choose the number of elements. Here you need to plug plot in dB. All the other field or menu, some I never used, to be honest, and we are going to use later on. So according with that, now you are ready to check your antenna. First, what you need to do, you need to set up your tiny essay. So it's very simple. You power on. Yep. You choose a mode. Low out. And here you have the output. So I'm going to set the frequency 14.010 megahertz. Here you can adjust the level. It's up to you. So yeah, there is one thing very important. If you can, the perfect distance where you are going to install the tiny essay from the antenna towards the antenna will be 2 wavelengths. Is according with radio engineering. This is all the radio engineer, they check antenna and so on. But sometimes it's not very, very possible. But if you can, put the tiny essay about 2 wavelengths from the antenna. So now you need to hook the antenna. Sorry, I have only one hand, and with the other hand, I need to hold the camera. Okay, so you put vertical and so on. What you need to do now, you just put on, and we are going to install the tiny essay. So the antenna is ready. I already beam the antenna towards the tiny essay. This is what you need to do. When you need to calibrate the polar plotter, you need to beam the antenna towards the generator. So I put on. Okay, everything is okay. I'm going now to install the tiny essay towards the antenna. Okay. Hold on. Sorry about that, I'm not a video shooter expert, Okay, so So if you can see here, there is my antenna. So I'm beaming, you see, towards the TNESA. Okay, sorry about that. The antenna is not hooked properly. Okay, so it's on. You see the antenna here, the TNESA, towards the cubical quad antenna or a beam antenna. So now I'm going back to my computer. Yes. Hop. You will see it's very, very straightforward and it's very useful, I can tell you, because according with also this kind of measurement, you can also achieve your setup, your fine-tuning for your antenna. Means, for example, to maybe got more directivity, more gain, and so on, because this is beam antenna. You cannot have both, in fact. You can have a lot of gain, but a lower directivity, or more directivity. That means more attenuation front and back ratio, but less gain. It depends. In fact, you need to adjust. It's a compromise regarding beam antenna. So everything is ready. The rotator is ready. So now I'm going to calibrate the input. So I show you. So what you need to do, on the transceiver, the AGC must be off. I put off. Yep. So this is mostly what you need to do. You need to play with your RF GAN and AF GAN. And now what we need to do, this is to calibrate the input. So to calibrate the input, what you need to do, you increase the volume until you reach the maximum. When you reach the maximum, so I increase, you see. Now I decrease a bit the volume until it starts to decrease. Yeah, now it starts to decrease. I put it back in order to achieve the maximum. Don't put too much because the system will be saturated. So now it's perfect. Yeah, it's perfect. Now I'm ready to check my radiation pattern and directivity. So you need to click to collect data and to move the antenna 360 degrees. Here there is a rotation time. You need to set up according with your rotation time of your rotator. It depends. All rotators are different. You need to play a bit until you need to check the time when you run about 260 degrees, how many seconds it takes. So you need to adjust here on the rotation time setup. More or less, this is all you need to do. Antenna element 2, polar plot in dB. Okay, I'm ready to go. So I'm going to calibrate collect data, and I start to move the rotator. So it start moving. So for the moment, the pattern still at the maximum level. Okay. Start to decrease. We're on the side. Yeah, start to decrease, start to decrease, start to decrease. Okay. Okay. Now it's going to increase a bit. I am still on the side, but now it's increasing. Yeah. Increasing. Yeah, not so bad. So I check the antenna on 20 meters band. And this is we can say the less favorable band, but by the way, my radiation pattern is very, very good. Okay, I'm done. So when done, okay, so now you are ready to collect data. So you can notice here the radiation pattern is already very good. So you remove the plot in dB, Oh, nice. Sometimes you can have some spike. It's according with sometimes some spurious from the audio on some statics. On what you can do here, you can do smooth to make it smooth, to make it nicer. You click many times. So you see, yeah, the radiation pattern is quite good. I lose a little bit of gain here, just a bit, but I have a very good front and back attenuation. So it's a compromise. This is my setup. Previously, I have more gain here, but less attenuation on the side, and the rear was not as good. So it's a compromise you need to achieve with your antenna. One more thing I forgot to tell you, you are on USB mode all the time when you do this kind of setup. Don't put in CW, because on CW with the filter, the system cannot detect the audio change. So you set up the carrier from the TNSA on 1000 Hertz. So that's it. So you can check all your frequency and so on. It will provide you some nice, of course, it's not a lab tool, you know, but it provides you a very good idea about the antenna directivity, front and rear attenuation and side attenuation. It's very useful to check your antenna system, because some people are not so lucky. Sometimes you are surrounded by a very bad environment with a lot of constraint. So it's better to check, and also when you finish to set up your antenna or to build your antenna, it's also a good software to check your antenna radiation pattern. So that's all. I think I forgot nothing. I promised to one of my friends to shoot this video. So I wish you a best 73. Take care, guys, and see you very soon on the air. This is Victor 85 November Papa Victor on QRT. Bye-bye.